All right, thank you so much for joining us today. And in this video, we are going to explain some tips and also solve some example. So stay here with me. Okay, let's start. So the first one, we are looking at entire derivative or antiderivative or integration, right? We want to explain that. So let's start like by saying that if I assume that um, f of x is equal to big F of, let's say, x, then what can I say? I can say that then you know small f, right, is an entire derivative or antiderivative of f. So what we mean is, like, when I integrate f of x dx, this is going to give me big X plus c. So that is the meaning. And basically, this one that I've written here is also having a meaning, which we have, which the question is already asking us that we should talk about indefinite integral. So indefinite integrals is kind of something like this. So this is indefinite, right? Indefinite means that we don't have limit for that. So we don't have limit here, and we need to add just a constant. So this one become indefinite what? Integral, right? And the question also asking for the fundamental theorem of calculus. And basically, we know that for the fundamental theorem of calculus, we are looking at AB f of x dx, and when I integrate this, I'm going to have big F of x from a to b, and this is big B minus big A, right? Something like this. So this becomes the FTC. So in maths, when you say FTC, we are talking about the fundamental theorem of calculus, right? So that will be the first one. Let's look at two. How is a definite integral different than an indefinite, right? So as we are saying, when we are talking about definite, as we just did it here, which is definite, like definite is kind of the fundamental theorem of calculus. So kind of we have something like integration from a to b f of x dx. But basically, you can see that all the integration that we are doing where we have the limit, we are actually talking about area, right? So this one is kind of, we are going to say this one is the area under the curve, right? So anytime you have this one, we are talking about area under the curve. And what are we even talking about? This is the definite integral that we are talking about. So this is definite integral. Let's look at indefinite. So what is indefinite? Indefinite, we just did it above there. So the indefinite is when we have plus a constant, right? So anytime we are talking about, indefinite, then what we are doing is we are trying to find the function that we differentiated. Remember, when you are dealing with integration, so f of x dx is equal to the big F of x plus c. So for example, if I'm integrating x dx, I'm going to have x squared divided by 2 plus c. What is here? This is like basically the function that we differentiated, right, to get this. Because when I differentiate this, I'm going to have this. When I differentiate this, I'm going to have x. And when I differentiate the constant, I'm going to get 0. So I'm getting the x, right? So this is like the family of what? The antiderivative, or like kind of trying to find the original function that, you differentiated, kind of something like that. Then what does this notation mean? I think we've done something like this here. So this notation is basically the TFC, the fundamental theorem of calculus, right? Yeah. So basically this is kind of the big F of A from A to B is basically the same as F of B minus big F of A. And this is the same as, remember, when we are integrating small f dx, right? So basically, this is what we are going to get at the end of the day. Let's look at 4. So 4 is kind of using the theorem that we just learned, which is the same as this. So this one I don't need to do integration. So big F of x from 1 to 5 is equal to big F of 5 minus big F of 1. I have my big F already here. So all I need to do is just do substitution. So 5 squared plus 5 minus 1 in parentheses minus plug in 1 in parentheses. So 1, the first one is going to be 25 plus 4 minus 1 plus 0. This is 29 minus 1, and this is going to give us a big 28. Yes, so this is what I'm going to get for. Now let's look at 5. So shade the area calculated by this integral, right? So what we need to do, we need to pick our f of x. Let's assume that this is small f of x, right? So we have small f of x, but remember anything that we have here is like f prime, but we are using it as f of x. So 2x plus 1, then we pick our x to be 0 and 3. So let's try and draw a table. So we have x, we have f of x, and we have 0, 3. Let's find f of 0. Let's find f of 3. So what is f of 0? Plug in 0 here. I love 0 when I'm dealing with polynomial, because as soon as I plug in 0, I get the constant. So I get 1 here. Then when I plug in 3, 6 plus 1 is going to give us 7. Good. So let's try and sketch, because that's what the question is asking us. So sketch, sketch, sketch. So I have 0 here, and 0 is going with 1. So let me plug in 1 here, and this my graph is going to be. So learn how to do the shading, and then I have 3 here, and 3 is going with 7. So let me assume that 7 is here, and this is where my point is going to be, right? So my graph is going to be like this. Then I need to join them. Good. And then basically this one too is going like this. So the area I need to shade somewhere here. My graph is very nice. Yes. Good. Now the next question is calculate the shaded area using geometry. Good. So we want to use the geometry, not the fundamental theorem of calculus. So what I'm going to do is I'm going to divide this into 2. That's what I like the most. Then I will name the first one area 1 and the second one area 2. So it means that now I have this rectangle here and I have this right angle triangle here. Now what is the distance from here to here? 3. Yes, it's true. What is the distance from here to here, or from here to here? It's 1, right? Because from 0 to 1 is 1. Then what will be the distance from here to here? So it's just between this. So 7 minus 1 is going to give us 6. Good. So now we can find area 1. What is area 1? Area 1 is like right angle triangle. So half base height. So half. What is the base for this? The base here is the same as this. What is 3? So times 3 times. What is the height? The height is 6. So times 6. So this is going to be 3 times 3, which is 9. Is that right? Yes. 2 cancel this one, 3, and we get 9. Let's look at area 2. Area 2 is rectangle. So base some height, and the base is 3, height is 1. So we are going to have 3 times 1, and this is going to give us 3. So what is the area shaded? Is going to be big A plus A1 plus A2, which is going to be 9 plus 3, and this is going to give us 12. Nice. Now C is we need to use the FTC, right? The Fundamental Theorem of Calculus. So we just need to do the normal integration. So I'll just write the integration again and just do it. So from 0 to 3, 2x plus 1. Right? So I'm just writing this one and just do the normal integration that we do. So this is 2x squared divided by 2 plus x from 0 to 3. So you know what we did? This is the degree 1, so plus 1 divided by 1 plus 1, 2. With this here, when I integrate a constant, I need to multiply by what I'm integrating with respect to x here. So x times 1 is x, and we have that. Let's plug in 3, or let's simplify. This is x squared plus x from 0 to 3. Plug in 3 and you get 3 squared plus 3 minus, when I plug in 0, I get 0. So this is 9 plus 3 minus 0. And you can see that 9 plus 3 is 9 plus 3. It means that we are going to get a big 12. Right. Good. So that is question 5. Now let's go through question 6. So question 6 is like definite integrals, like what we just did here. So we can just use the FTC, right? We don't need to go and look for the area, those kind of stuff. It's kind of a lot. So let's go. Let's integrate for x. What do we get? X squared divided by 2 minus 6x. So you see that now we are getting used to the integration, so we can just write them very nice and very fast. So this is going to give us 2 cancel here, 1 cancel here, 2. So we are going to have 2x squared minus 6x from negative 1 to 3. Plug in 3 and negative 1, and we are going to have 2 times 3 squared minus 6 times 3 minus 2 times minus 1 squared minus 6 times minus 1. So you see the way I've put in this one into parentheses is because of this guy here, minus. So this is going to give us 2 times 9 minus 6 times 3 is 18 minus 2 times 1 plus 6. So 18 minus 18 minus 2 plus 6. And this is 0 minus 8. And we get a big minus 8 as our final results for the first one. Good. So let's look at the second one. Second one, the same fundamental theorem of calculus. And this is also still the definite integral. So let's go to x to the power. So it's 3. So it's supposed to be 4, and we divide by 4, right? So this is 3. So we add plus 1, we divide it by that. Plus this is 1. So we add plus 1, 2 divided by 2 minus 9, and then we multiply by x. Then we are moving from 0 to 2 to 4. So when we do that, we are going to have, I think I need to shift these guys up a little bit so that we can get a space for them. So this is going to give us x to the power 4 divided by 2 plus x squared divided by 2 minus 9x from 2 to 4. So let's plug in 4. What do we get? 4 to the power 4 divided by 2 plus 4 squared divided by 2 minus 9 times 4 minus open bracket 2 to the power 4 divided by 2 plus 2 squared divided by 2 minus 9 times 2, close the bracket. And basically, what are we going to get? Let's shift up small. So we are going to have 4 squared is like kind of a lot. So 4 squared should be like this is 6 1 5 2. Okay, 4 squared should give us 4 to the power 4 should give us 2 4 5. The one we divide by 2, we are going to get 1 2 8 plus 4 squared is 16 divided by 2, you get 8. Then 9 times 4 is 36 minus 4, 2 to the power 4 is 16, yes, divided by 2 should give us 8 plus 4 divided by 2 should give us 2, and then this one is going to be is it minus 18 or plus 18? Okay, kind of like minus 18. Yeah. And then what can we do? What we can do is let's shift this guy this here, and then let's continue from here. So kind of when I add this to this, I'm going to have 136 and subtract this one from it. So I'm going to get 100, right? And then this people here is going to give me minus 8, and this is going to be 100 plus 8, and this is going to give me a big 108 for the B. Let's just finish it up. Okay, we are almost done. C, D, and then we do the last question. So let's look at this. This is going to be, I'll factor the 3 out. 1, 2, 1 over x squared dx. Since the degree is not 1, we are not thinking about the natural log. So still 1 to 2, x to the power minus 2. So 3 minus 2 plus 1 divided by minus 2 plus 1. This is definite, so we have the limit there. And this is 3x to the power negative 1 divided by negative 1 from 1 to 2. And then still we are on it. This is going to be minus 3 and then times x to the power minus 1 from 1 to 2. I love simplification. So minus 3 divided by x from 1 to 2, and now we can plug them in. So plug in 2, get minus 3 over 2, minus plug in 1, get minus 3 divided by 1, and this is minus 3 divided by 2 plus 3, and this is going to give us 3 divided by 2. Is that right? This is kind of divided by 2, and this one is going to be 6. So minus 3 plus this is kind of going to give us 3. So yeah, that's right. That's right. Let's do the D here. So now this is 1 over x. So we need to think about the natural log. And basically we need to put like absolute of x. But the idea is that we know that the limits here is not negative. So we can just ignore the absolute, because we use the absolute because we think maybe when it is minus, mostly when we are dealing with indefinite, right? We don't know the limit. So this one, I'll plug in e to the power 3 minus e. This is to the power 1. So this is kind of beautiful. This is going to be 3 minus 1, and this is awesome. We get 2. Right. So you see that this guy will cancel this guy. So like they are inverse for each other. So this one and then this one to go away, and then we have the 1. Let's do the last one. And the last one, we are going to write our final answer to be very big, because that's our final question, right? So let's go through that and see what we are going to get. So we want to find the average value. So we need to do integration, and the integration here should be 1 divided by b minus a, integration from a to b. This is gene, so this will be gene of x dx. So what are we going to do? What is our a? This is a, this is b. So we are going to have 1 divided by 3 minus 1, integration from minus 1 to 3, 3x plus 6x squared or the x. We are almost getting it done. So this is going to be 1 divided by 3 minus is 3 plus 1, which is 4. And then let's do the integration. 3x squared divided by 2, because this is over 1, is to the power 1, plus 6x to the power 3 divided by 3 from negative 1 to 3. This is 1 over 4, and simplify, you get 3 over 2x squared plus 3 times 3, 3 to 6. So this is like 3 to 6. We have something like this. and then from -1 to 3. Let's plug in the values. 1 over 4, plug in 3, 3 over 2, 3 squared plus 2, 3 to the power 3, minus, I open a parenthesis, 3 divided by 2 minus 1 squared plus 2 times -1 to the power 3. Close it very nicely. Okay, we need space, so let's shift this guy up here. Let's shift the rest also up there, right, so that we can get the space. Oops. Okay. So let's do that. Let's simplify. Now this is kind of 9, right, squared. So 9 times 3 is 27. So 27 divided by 2 plus 9 to the power 3 is also 27. So 27 times 2 is going to give us 4154. Good. You said it. You are right. Minus 1 squared is still 1. So 3 on 2 and minus 2. So what can we do here? Let's try and simplify. So 1 over 4, 54 times 2 is 8, 108. So this is kind of, this one can be written as 108 divided by 2. So 108 plus 27, 5, 1, 3, 135. So we are going to have 135 divided by 2 minus, this is also divided by 2 times, so this will be 4. So basically this is going to give us -1 divided by 2. Let me clear some of the solution so that we can push some up and then we have some space down. Good. So let's finish hard. 1 over 4. Don't forget, you are coming to write our answer very big. That is our final results. So we are almost done with the hard work. So now let's add. We are going to have 1 over 4. The one you add, we get 136 divided by 2. 136, we can divide it by 2, I'm sure. 136 can be like 2 goes to 13, how many? 12. 1680. Is it true? Let me multiply. I want to multiply this one. Okay, yeah, that's right. Then I think 2 can go here 2 and go here 34. Is that right? Yes. And then 2 again can go here 1 and go here 1, 7. Oh, that is nice. So our final result is very big. We are getting a big 17 as our final results. Woo! Right. So this is the final question that we needed to do. Yeah. Thank you so much for staying here, learning with me, and see you in the next video.